Hello guys! Welcome in the next video of the Databricks series. In this video, let's go through how to use PySpark Vacuum and optimize example in Databricks. We are taking as simple as so we don't have any issue in understanding. Let's click on PySpark Vacuum and optimize notebook, where we need to understand how PySpark Vacuum works in SQL and in Python. As you can see, our Python interpreter is selected and our cluster is also up and running. Let's go in the first cell. As you can see, we are trying to create a new product table with few number of columns. This is a sample product table which we need to see how vacuum works on the top of it, and it's nothing to do with the data. Let's execute this cell. As you can see, it's trying to run the query. Now it's giving OK. That means the table is created. Let's go in the next cell. In the cell, we are trying to insert a statement using the insert command, and we are taking only one single record into. It is a simple insert statement. We should be already aware of this. That means if you execute one insert statement, and we have only one part file created for this table. Let's click on the catalog menu now. Click on DBFS, then user, then Hive, then warehouse and product. As you can see, we have only one part file available behind the scene. Let's go in the next cell. In this cell, we are trying to run two different insert statements. We have two different insert statements and two different records. Let's execute this cell and click on the catalog menu now. Click on DBFS, then user, then Hive, then warehouse and product. You can see we have two different part files are created for two different insert statements. That means if you try to insert one single statement with one record, then it will create one part file for it. If you try to insert two different statements, then it will create two different files. And these are very small files in which we have only one record available, means few columns, values available in one single part file. That means these are very small files. Let's go in the next cell. As you can see in this cell, we are trying to insert the same statement, but we are taking three different records with multiple values. This is a kind of statement where we want to insert multiple records with one single statement. Usually we call it as batch statement also. We also want to experiment this. What happens behind the scene when we try to insert multiple records using one single insert statement? Click on the catalog menu now. Click on DBFS, then user, then Hive, then warehouse and product. Now you can see we have only one part file created for that. That means if we try to insert one statement and it creates only one part file, even if you have multiple values for it, and all the values will go in that part file. Now we want to go with the optimized statement. This is the keyword which is basically available in Databricks only, and it is used to optimize the performance of the data delta lake tables. And if you say performance, that means we are specifically talking about the select statements or the select queries which we run on the top of these tables. So let's say we have inserted so many records into one table and now it's not performing well. So one way to see this kind of issues to go, what if we have multiple insert statements and it should have been created multiple part files, and which are very small files. So these small files create problem in the select query. So better is to create one large part file behind the scene rather than creating multiple small files. And what happens when we have created already multiple small part files, or we are inserting data with insert statements, and this is very frequent and it is creating part file, then we can only run optimize command. And this command is basically to go with multiple small part files, combine them into one file, and then we retrieve the data from that one large file. So this is the kind of command basically which does all of these tasks, combining all small part files and putting those files into one single large file. Maximum file size for the large file can be up to 1 GB. And if we have partitioned our data previously, then it will also consider that partition level. So within the partition, it will combine all the small files and will create large file as per the partition. Let's execute the cell, and in the results that you see, we have available for our product table location, which we have already seen. And now you can see number of files removed or number of files added. One, that means one new large file will be created out of those 4 files which we created last in the last cell. So all kind of metadata information is available in metrics column, and you can go through with the metrics result column. I also want to show you what is the impact on DBFS. At least click on the catalog menu now, click on DBFS, then user, then Hive, then warehouse and product. Now you see nothing happened over here. 5 files already available in this file. And if you remember, optimize command basically has run already. But that process will not take impact immediately. It will take time to process that data because cluster is up and running right now. And if we do this stuff currently, then it will impact on the select queries which are running currently on this table. So as soon as you run optimize command, then it will not take effect immediately, but it will take some time, and then it will process and it will create one large file. Let's go in the next cell. We have describe history command. Let's execute the cell. As you can see in that we have all the commands written which we have already run on this table, which are available in the result set. We have that optimize command, and the latest record is also available. That means optimize command has run already. Let's go in the next cell. We are trying to see how select statement works on that. Does it have any impact of optimize command and select statement? Now you can see we have the similar result available. That means we don't have any issue on the top of select statement till now after running our optimize command. That means all optimize statement will work later on. So current user with current select statement will have not any issue on this. Let's go in the next cell. We are running ls command. We want to see what is there in the product folder, and we want to use the ls commands to see that. As you can see in the result set, we have few files available, and delta lock folder is also available. Let's in the next cell, we are talking about the vacuum command, and this command is basically used to clean up the old Delta Lake table. Or when the table is updated or deleted, then it will delete all the unused file from the storage. This is because data maintain history of table versions, and which we can remove using this vacuum command, and it can also free up some of the stories. So this can also reduce the cost of the storage. It identifies and removes files that are no longer referenced by Delta table, and older files can be removed using the vacuum command. Let's go in the next cell with vacuum product. Dry run command is basically used to clean up all of the unnecessary files available in this table available on the DBFS location. You can go in the DBFS again. You see nothing happened over here. That means it will not take effect immediately. It will take some time, and it can also make the history available. With us means the retention period for the older files. That means that files are not automatically deleted immediately. It will take some time to delete those files until that file is not deleted. If we want, then we can also recover those files back. Let's go in the next cell with vacuum product retain. 720 hours dry run command is basically used to clean up all of the unnecessary files available in this table available on the DBFS location. Not take effect immediately. It will take 720 hours time to delete all delete operations. Till then, if you want, then you can also recover data back, and it can also make the history available. With us means the retention period for the older files. That means that files are not automatically deleted immediately. It will take 720 hours time to delete. Let's go in the next cell. The configuration property in Apache Spark with Delta Lake is a safety mechanism designed to prevent accidental data loss during operations such as vacuum. When this property is enabled, set to true by default, Delta Lake ensures that the retention duration for deleted files is at least the minimum retention period, which is usually 7 days before allowing their permanent removal. This check prevents users from inadvertently deleting data that may still be needed for time travel or recovery. If you wish to bypass this check and set a lower retention period, you can disable it by setting the property to false, but this should be done with caution, as it increases the risk of irreversible data loss. That's all we have for this video. I hope you learned something about Databricks. See you in the next video.